Hello, I'm back to give you another online lesson. We're going to pick up page 19 of the course packet. We're going to pick up at the very top of the page where it says Empirical Rule. And the Empirical Rule is used for normal distributions. The normal distribution is symmetric and bell-shaped. And there's some important properties that we can follow when we know that the distribution of a variable is symmetric and bell-shaped. So the empirical rule states that 68% of the observations are within one standard deviation of the mean. It also states that 95% of the observations are within 2 standard deviations of the mean. And then finally 99%, so almost all observations are within 3 standard deviations of the mean. Okay, so I'm going to do a demonstration to make that a little more clear. Let me go to StatCrunch. And we have some data that was collected on the number of calories consumed in a day. And I'm going to go ahead and make a histogram of that variable. Okay, I could just hit Create Graph, but I'm going to give it a couple instructions here. Okay, so here's the histogram, and you can see the histogram is symmetric and bell-shaped. In fact, we can even put a curve over that. And so we overlay a density curve that follows a symmetric and bell-shaped curve. This is the normal distribution. And the numbers above the bins are the heights, or the number of people. So we surveyed 500 people. So all these numbers would add up to 500, and 4 of them had between 800 and 1,000 calories that day. 10 people had between 1,000 and 1,200. Okay, so we can use the empirical rule and see if that works on this data set. I'm just going to round the mean to 2,000 and the standard deviation to 400 just to make the calculations a bit easier because it correlates to a bin width and the center at 2,000. So that's going to make the calculations easier, but in practice you probably shouldn't do that. Okay, so I'm going to open up that histogram. So here's the histogram that we were just looking at. And the empirical rule states that 95% of the observations are within 1 standard deviation. So like I said, we're going to just round this to 2,000 and this to 400 just to make things a bit easier. Okay, and so here's the mean at 2,000, and we want to go 1 standard deviation below and above. That's 68%. So if I take 2,000 minus 400, that's 1,600. That's right here. Oops, there we go. And if I go 2 standard deviations above, that would be, 1 standard deviation, 2,000 plus 400, that would be 2 bins. And so that's right there. So 1 standard deviation would go between 1,600 and 2,400. Whoops, that's a 4. And according to our empirical rule, that should be 68% of the observations. So we can see if that actually holds. And so we have 500 observations, and these are the observations within 1 standard deviation right here. So I count 71 plus 90 plus 92 plus 82. And I'm going to divide by 500. And so that's equal to That's equal to 0.67 or 67%. Okay. And so that's pretty close to 68%. We did some rounding here, and nothing ever follows the normal distribution perfectly, but that's pretty close. And now I want to go back to the rule and do the 2 standard deviations. So 95% should be within 2 standard deviations of the mean. So let's go back to our histogram. So 2 standard deviations would be 2,000 plus 400 plus 400, or plus 2 times 400. That's going to be 2,800 for my high, and 2,000 minus 800. And so that's going to be 1,200 for my low. Okay, so 1,200 is right here, and 2,800 is right here. So according to the empirical rule, 95% should be in here. So again, I can count up the heights of these. So here's 23 plus 45 plus 71 plus 90 plus 92, 82, 49, and 24. If I sum those up and divide by 500, so that's going to be 476 divided by 500. That's going to be equal to 0.952, or very close to 95%. So here's a normal distribution, and we can see that it does indeed follow approximately what we just said with the empirical rule. Okay, so that's the empirical rule. We'll go ahead and work on an example. It says heights of women have a bell-shaped distribution with a mean of 63.6 inches and a standard deviation of 2.5. Use the empirical rule. Find the approximate percent of women between 56.1 and 71.1 inches. Okay, so we're going to use this rule and figure out how many standard deviations away from the mean a value is. Okay, so we know that the mean is 63.6. And if we wanted to subtract 1 standard deviation, that's going to be equal to 61.1. And we can add 1 standard deviation. And that's going to be 66.1. And actually, this is a 1, not a 6. Oops. So 60, I'll just cross all that, 61.1, sorry. Alright, so this is 68%. That's within 1 standard deviation because we added and subtracted 1 standard deviation. Okay, but that we didn't get that far yet, right? This is much further out. So let's try 2 standard deviations. So we're going to take 63.6 plus 2 times 2.5. And that's going to be equal to 58.6. And we can add 2 standard deviations, or I'm sorry, this is subtraction. Now we're going to add 2 times 2.5. And so this gives us 68.6. Okay, still not the numbers we're looking for, but that's 95%. So hopefully it's in within 3 standard deviations, and that would be our answer, 99.7. So if you take 63.6 plus 3 times 2.5, that's going to be equal to 71.1. That is one of the numbers. And if we subtract 3 standard deviations, we get 56.1. So 3 standard deviations, so the correct answer would be 99.7.